So let's think about a problem so this would be example 4, that doesn't have a log on both sides. So how do we solve that? You solve this the way that you would solve any equation. You solve it by doing the inverse operation. And we know that exponents and logarithms are inverse operations. So since this starts off in log form, I'm going to have to turn it into exponent form to solve. So I know that this turned into an exponent form, log base 2. The 2 is going to go to the other side of the equal sign and become the base value. So this side is going to be 2 to the 4th equals x. And 2 to the 4th is 16. You can see in reverse how that would work. Log base 2 of 16, log base 2 of 2 to the 4th. We'll pull a 4 to the front, and log base 2 of 2 is 1, so you get 4. So you can see how that pans out. Let's do another example here. Log base 5 of 3x plus 1 equals 2. So if it starts off in log form, to solve, I have to change it to an exponent. So since this is log base 5, the 5 goes to the other side and becomes the base value, and it equals the answer. So 3x plus 1 equals 25. Subtract 1 from both sides. So x equals 8. Now I better go up and check to make sure that actually works. 3 times 8 is 24. 24 plus 1 is 25. And it's okay to have a positive 25 in that place right there. Here's the next example. Again, you may want to start pausing, trying these. Log base 4 of x plus 3 equals 2. So I'm going to start by, since it's a logarithm, I'm going to turn it into an exponent. So x plus 3 equals 4 to the second power. And 4 to the second power is 16. So x equals 13. And if I put 13 in here, that's good, because I would make a positive 16 in that spot, and that's fine. Okay, let's take these up a notch here. Let's go do example 7. 4 log base 3 of x equals 28. So this is what this means. I have 4 times this equals that. So I first have to get this logarithm by itself before I can change it to an exponent. So I'm going to start the whole problem by dividing by 4. So I have log base 3 of x equals 7. So then I'm going to change it to an exponent. So x equals 3 to the 7th power. And then I'll have to use my calculator for that. 3 times 3 times 3 times 3 times 3, 7 times. And I get x equals 2,187. And it's okay to put a positive number there, so that's a good answer. Okay, let's try this one. I'll get another piece of paper here. Number 8. Two natural log of negative x plus 7 equals 14. Now when I saw this problem and I saw a negative x right here, I thought to myself that the answer is going to have to be negative, because if I overall want this to be positive right here, x would have to be negative. So I'm going to start by subtracting 7. Then I'm going to divide by 2. I'm going to go ahead and make that 3.5. Then I'm going to change this from a log to an exponent. So this means log base e of e to the x equals 3.5. So negative x equals e to the 3.5 power. So then, to get the x by itself, I'm going to divide both sides by a negative. So I have x equals negative e to the 3.5 power. And that's something I'm going to have to do in my calculator. The E button is right above the division key. So I'm going to type in negative e to the 3.5 power. And I get negative 33.11. You could also do that on the TI-30. I'll show you on that one. So on that one, the E is, I have to find it because I'm not familiar with this calculator, it's right above the LN key. So on that one, I'm going to type in negative second ln to the 3.5 power. Example number 9. Negative 6 log base 9 of x plus 8 equals 0. So I'll start this one off by dividing by negative 6. So I get log base 9 of x plus 8 equals 0. So x plus 8 equals 9 to the 0 power. And any number to the 0 power is 1. Subtract 8 from both sides and you get x equals negative 7.